In this presentations, we are going to discuss about computer system in Introduction to Operating System. The contents are overview of operating system, what operating system do, computer system organization and computer system architecture. The objectives are describe the general organization of a computer system and the role of interrupts, and describe the components in a modern multiprocessor computer system. The overview of OS is the set of program is a software. There are two types of software, system software and application software. System software which is used to run our system or machine. The application software, it is used to perform the user needs and applications. So the operating system is defined as it is a system software used to run a system based on user commands. What does the term operating system mean? An operating system is fill in the blanks, that is about the car, airplane, printer, washing machine, toaster, compiler, etc. So what is an operating system? A program that acts as an intermediary between a user of a computer and the computer hardware. Operating system goals are execute the user program and make solving user problems easier and make the computer convenient to use and use the computer hardware in an efficient manner. These three goals are maintained and achieved by operating system. What is a computer system structure? The computer systems can be divided into four components: hardware, operating system, application programs, users. Where the hardware which provide the basic computing resources, that are CPU, memory, IO devices. The operating systems that control and coordinate use of hardware among various applications and users. Application programs that define the way in which the system resources are used to solve the computing problem of a users. So that is a word processor, compiler, web browser. So the user applications or needs to be performed by the application programs. The users are people, machines and other computers. Next, abstract view of component of a computer. So actually the user can interact with the computer hardware using an operating system to perform the application programs. What operating system do? Depends on the point of view. User can convenience, ease of use and good performance. Here the operating system don't care about resource utilization, but shared computer such as mainframe or mini computer must keep all users happy. Operating system is a resource allocator and control program making of the efficient use of hardware and managing execution of user programs. And the user of dedicated systems such as workstations have dedicated resource but frequently use shared resource from servers. So the definitions of operating system, the term OS covers many roles because of migrate, design and use of OS, and present in toaster through ships, spacecraft, game machines, TVs and industrial control system, born when fixed use computers for military became more general purpose and needed resource management and program control. So the operating systems is defined by a program, that is a single program, that's an one program running at all the time in the computer. So it is acts as a kernel. So the kernel is the main heart of our computer. So it is perform user applications by the system program and the application program. So the systems to be operated by the system program, the applications as the user's needs are performed by the application programs. So overview of computer system structure. In this computer system structure, the main constraint is computer system operation, because one or more CPUs device controllers cannot through their other device. So it can be connected by the common bus, providing access to share the memory. And the concurrent executions of CPUs and the device computing for the memory cycle is also essential. So the bus is the connecting device, the connecting unit. It is used to connect the processor to the internal and external input and output devices with the memory. So the computer system operations. So the I/O device and the CPU can execute concurrently. So through the I/O device it can collect the input and finally transmit the output to the output device. These are connected or interface with the CPU. Then each device controller is in charge of a particular device type, and each device controller has a local buffer for storing the temporary data, and each device controller type has an operating system device driver to manage it, the device driver to manage or control the process, and the CPU moves data from or to main memory to or from the local buffers. Then the I/O is from the device to local buffer of controller. Then the device controller informs the CPU that it has finished its operations by causing an interrupt. So the common functions of the interrupt. The interrupt transfers control to an interrupt service routine. Generally, here through the interrupt vector, which contain the addresses of all the service routines. So the interrupt architectures must save the address of the interrupted instructions. A trap or exceptions is a software generated interrupt caused either by an error or the user request. An operating system is a interrupt driven also. So the interrupt timeline is also maintained. So if it's a process is done in the appropriate time but it does not exist with the appropriate time, the interrupt signals are used to exit that process and continue to the next one. So in this interrupt handling we have to point and mention the following constraints. The operating system preserves the state of the CPU by storing the registers and program counters, because the program counter which give the address of the next instructions to be executed. So this can't be preserved, okay, when the interrupt signals are occurred. So next determines which types of interrupt has occurs. So based on the types of interrupt we can perform the next preventive actions. Then the separate segments of code determines what action should be taken for the each type of interrupt. So then this interrupt cycles, the CPU is a processor, so it in one processing. At the same time the interrupt signals are interrupted, so the handler, which is interrupt handler, process the data and return from the interrupt. Then the CPU resume to the external process, then make that, then produce that output. So here, when the interrupt occur, the processor must store the previous state of the executions, and after the interrupt completions, it must go to the previous stage, that's in recall the previous stage for the further executions. So the IO structures two methods of handling the IO. After IO starts, control returns to user program only upon IO completion, and after IO starts, control returns to user program without waiting for the IO completions. So after the IO start, there's an input output operation starts, the control returns to the user program only upon the IO completions. Whatever, if the previous process is completed, then only it can accept the next one. In the same way, when it return a value to the output device, so the control returns to a user program only upon the IO completions. So in that time it make or it have the following possibilities: wait the instructions idles the CPU until the next interrupt, wait the loop, and at most one IO request is understanding at a time, no simulations IO processing. So in the second state, after the IO starts, control returns to the user program without waiting for the IO. If it does not waiting for the IO completions, so in that time it move by the system call or device status tables. So the system call requests to the OS to allow the users to wait for IO completions. So the system can have some executions time, that they also give us some waiting time for that process. Next, the device status table contains the entry for each IO device indicated its type, address and states. So in this computer system architecture, the most systems use a single general purpose processor. So the most systems have a special purpose processor as well as a microprocessor systems grown in use and in use for the further processing. So in this, some importance are identified. Here the parallel systems and tightly coupled systems also managed. So the advantages are it may increase the throughput, economy of the scale, and increase the reliability. It has two types: asymptotic multiprocessing, symptotic multiprocessing. Okay, thank you.